Alright guys, we're going to begin Unit 10 here. Unit 10 is going to be about these things called logarithms, but today's lesson is not going to be about logarithms. It's going to be about something that kind of gets us ready for logarithms. We're going to talk about inverse functions. So if you want to title up your notes there, go ahead and do so. I'll leave that up there for a little bit for you. Here. Let me give you guys a little thinking exercise here for a second to introduce the concept to you. So I'm going to give you two functions. This guy, and I'm going to give to you another function. That guy. And I'd like us to complete some exercises here. Alright, let's do would you guys go ahead and plug these numbers in for x, see what you get for y, and then I'll ask you guys what you got in just a second to this function over here on the left. Alright, so here's our answers. We got 4, 6, and 8 by plugging those in. Now I'm going to take these answers that you guys just got, I'm going to plug them into this function over here. 4, 6, and 8. Okay? Go ahead and plug those numbers into that function and see what you guys get. I'll give you a second for that. Alright, so these are the answers we should have gotten, and what Miles has observed there is exactly what I want you guys to notice, is that for this function over here on the left, if I plug in 0, I get 4. But for this function over here, if I plug in 4, I get 0. And the same thing holds for all of it. If on the left, if I plug in 1, I get 6. But on the right, if I plug in 6, I get 1. These two functions are what we call inverse functions. Inverses, or opposites of each other. Okay? So that's what an inverse function is. So let's go ahead and write down the definition of an inverse function here. All right, so I'll say it again, but just to explain this, what I've written on the board now, connecting that to what we just said. So suppose you have two functions, f and g. If I plug a into the f function and my answer is b, and at the same time that means that plugging b into g gives me a, no matter what a and b are, that means those two functions are inverses of each other. So that's what an inverse function is. So now, these two functions then have a special relationship, and since they have a special relationship, they're going to have a way of representing that they are that. Okay? So, let me show you guys what I mean by that. The inverse of a function call it f of x, is written like this. Okay, so on the last slide, I just showed you two functions, f and g, but since they're opposites of each other, we're going to say, okay, let's not call one f and one g. Let's call one from f, and then the other one we'll call this f with a little negative 1, which from now on is, I'm just going to say that means f inverse. Okay, so that's the symbol we'll use. Now, I could have, instead of changing g into f inverse, I could have changed f into g inverse. It doesn't matter which one you change. Just that they both have the same letter, just one has a little negative 1, and that means they're opposites of each other. Okay? And so that's basically what an inverse is. It's where if you plug a number in, the answer you get out. If you plug that into the other function, you get the original number. Okay? So that's what inverses are. So our goal for today is I'm going to give you an equation, and you're going to find the inverse function. Okay? So, for instance, if I give you guys 2x plus 4, and I tell you that's f of x, you guys are going to find out what f inverse is, which we already know what it is. I told you earlier today, it's this. So you're going to find that equation from this equation. Okay, so that's our goal. I'm going to give you an equation, say find the opposite equation. Right? I'll give you guys some steps for it, but that's the idea. So let's go ahead and we'll jump into our first exercise here. All right, let me bring this back into my tools here. All right, so go ahead and write down your directions there. Number 1, we'll call this example 1. All right, so I'm gonna do each step, but I'm gonna write some words for each step. I think it will help you. So I would encourage you guys to write the words down as well as I explain what the steps are. So step 1 is going to be to replace the f of x with a simple letter like y. Okay? And just so you guys know, it won't always be f of x. It could be g of x. It could be h of a. The letters don't really matter, but my point here is that for this symbol here, that's just the y value. That's all that represents. And it's a little bit big and clunky to work with. So the first thing I'm going to say is just to make things go smoother, just get rid of it and put a y there instead. It's just easier to work with. That's the only reason I do that. Okay? All right, now the next step is the key step. This is the inverse step. We're going to switch the x and y. We're going to switch the x and the y. Okay, remember how we said that, remember how Miles had pointed out with those tables, it was the fact that all the x's over here were the y's on this one and vice versa. Well, that's what makes an inverse an inverse. So, to change this into an inverse, what I'm going to do is I'm going to switch the x and the y's around. I'm going to put an x here, and I'm going to put a y here. Now, that's the inverse, just so you know. So, technically, our job's done, but not really. With functions, you need to have the y by itself. You can't leave the y like that. But technically, that's already the inverse. The job has been done, but we have to make it look right now. And this is the step that's the most problematic. It depends on your algebra skills. Every problem we look at will be slightly different at this point, but the next step, which is going to take us some time, is going to be to get y by itself. Okay, but how you do that will be different for every problem. So at this point, if I wanted to get the y by itself, what two things do I need to get rid of? I need to get rid of the half, and I need to get rid of the 1. If I can get rid of these two things, the y will be by itself, right? So now, how do we do that? Well, let's start with the half. How do we usually get rid of fractions? You multiply by the bottom number. Good job. So we're going to multiply by 2. That's something we're going to do. How about the 1? How am I going to get rid of the 1? Subtract it. So you do the opposite. So on the bottom means division. So to get rid of it, we multiply. Plus, the opposite is subtraction. So we subtract. So you do the opposite to get rid of these things. Now, what order you do these things in, sometimes it matters, sometimes it doesn't. I like to start with subtraction first, so I'm going to do that first. So minus the 1 on both sides, like that. So I get x minus 1 equals 1/2 y. And then we said, to get rid of the half, we're going to multiply both sides by 2. So times 2. I'm going to put this in parentheses because I have to multiply the whole thing by 2. So here, these cancel out, which leaves me with 1y. You don't really need to write the y. I'm sorry, the 1. You don't need to write the 1. Over here, we're going to have distribution gives me 2x minus 2. Now, I almost circled it. And that actually is a good answer. I think at that point you'd be able to find the right answer on a test. But just so you know, they'll probably write it like this instead. 2x minus 2 equals f with a little negative 1. Okay? So this step is not very important, but technically you want to replace the y with f inverse. And that's going to be our final answer. So now, on this function over here, I'm not going to show you the math, but on this function, if I were to plug in, let's say, 4, I would get 3 as an answer for this original function. I'm not going to have you guys work it out to prove it, but I'll just say that's what would happen. What should this look like then for this function? If I were to plug in all right, so remember what inverses are, they're things to do to switch. So if I were to plug in 3, I should get 4. If this is really the inverse of that function, that's what should happen. Let's do some mental math and just check it for the heck of it. 2 times 3 is 6. 6 take away 2 is 4. So there you go. So those are inverses of each other there. All right. Let's take a look at another one. Okay, so we are on this guy. So go ahead and let's write this one down. I'm going to have you guys walk me through it a little bit here. Next about this. Interesting. All right. All right. So Cal, what's the first step here? That's right. In this case, we don't have fx though, right? We have gn. So I'm going to be replacing. I see what's going on. It's frozen. I'm going to be replacing gn with y. That's my first step. All right. Owen, what's the next step here? We're going to switch the two letters around. So I'm going to put the N here, and I'm going to put the Y over here. Haley, what's the third step? Did you write down the steps on the paper? So what was the third one? Did you not write it down? Can you read it? You know, I give points for, I need you to call anyone. So I pass you up sometimes. I know you're shy, but you get points for this. It's kind of something you want to do. So I'll pass you up again, but make sure that you're kind of bold to answer out because that's part of your grade there. But I'll go on over here to Brianna. Brianna, what do we do next? What's the third step? I want to get y by itself. I want to get the y by itself. So now, at this point, the people I call on have a hard task because at this point, it's like everything's a little bit different. But I'm just kind of relying on your algebra skills. But take a guess. You get a point. If you're wrong, it's okay. I'll tell you the right step. So, Niana, if I want to get y by itself first, what would you do? Yep. Good algebra. Nice. So take away the 3. So that leaves me with n minus 3 equals 3 over 2y. Right? The 3's gone on the right. We got n minus 3 on the left now. Let's take a look at the next one there. Michelle, what's your thoughts on the next step? Dividing by 3 over 2 is not wrong. I'm not going to go that route, but so if you were to do that, like, how would you write that? So it probably looks something like this, right? That's not quite simplified. I'm not going to go that route, but you're not wrong. That would be right. What do you think, Cal? I'm going to kill the fraction by multiplying by the bottom. Yeah, so I'm going to multiply by 2. Don't forget when you multiply the other side by 2, if there's 2 things over there, you have to multiply both of them by 2. All right. It's not here. Not here. Not here. Brittany, what's next? Yeah. Now, this is a good answer. So the last step. That's interesting. Adriana, what's the last thing I want to do here? We could, I'm going to get to that in a minute so you're not wrong, but what's the last step we wrote down? Yeah. So now instead of f with a little negative 1x, what do you think I'm going to write down? G? Yeah. So we're going to use the letters they gave us, but it's the same idea. So now this answer is actually good. Now you said simplify. It doesn't simplify, but what we can do is we could write it differently. And since we have a multiple choice test, I want you guys to see both ways to write it because I don't know how they're going to give it to you. My software may not always do it the same. what you could do is you could split this up into two. You could say that this is 2 over 3n minus 6 over 3. So you guys see what I did there? I just put the 3 under each one separately. And this one can be reduced. If I do that, that one can be reduced. So it's possible they would write the answer like this. So this is an acceptable answer, but so is this. So just know that either one of these are okay. But on a multiple choice test, you should probably make sure you know how to work between each one, because we don't know which one it'll be. All right. I'm going to get you guys started with the next problem, and then I'm going to let you guys finish it and do another one on your own. Let's go ahead and take a look. All right. So, step 1. Well, I'll wait for you guys to go ahead and write down number 3. This is student practice, but it's a little bit different, so I'll get you started on it. Okay, so step 1, guys, is to replace the h of x with a y. Step 2 is to switch your x and y around. And here's where things get different. This is step 3. This is where we want to start getting that y by itself. So when you have the whole thing has a number underneath it like that, the first thing you want to do is get rid of the number on the bottom. That'll be the first step, just so you know. So on this problem, actually, when you have a whole expression over one number, we're going to get rid of the number on the bottom first, and that's by multiplication. So I'll do that first step for you, and that would leave us with this. But from there, I'm going to let you guys handle it, get the y by itself. Then go ahead and try number 4, which is pretty similar to this one, and then we'll see what you guys got. So these are like the basic idea. I have some other problems I'm going to give you guys, but I'm going to say these are like extra credity. So these are the ones I want you guys to know for sure. So if you're happy with that, you want to work on homework, you can. But if you want to try some extra credit problems, I might put them like on a quiz or on a test too, so you can get some extra credit quiz and test points. But I will show you 2 other types of problems where you can find an inverse. But I just wanted to show you just these ones. These are linear functions. We're going to look at some other functions now. But like I said, if you don't care about the extra credit, then you can just look at your homework for now and get started on that. But let's go ahead and take a look at these things here. So I think what I'll do is I'll do 2 samples for you, and then if there's some time, I'll let you guys practice some of these extra credit ones in class too. So I'm going to start with number 5. All right. So step 1, same. Replace this with y. Step 2, flip your x and y around. All right. So from here on out, I'll just take volunteers. If you want to share a thought, go ahead and shout it out. I'll give you an extra point. I won't use my cards for this, but if I wanted to get the y by itself, any thoughts on how I do that? Divide by -2. That's correct. So let's go ahead and divide both sides by a -2. All right, this next one I'm going to say is going to be worth 2 bonus points if you get it right. Still give you a point if you try. I'll give you bonus points if you get it right. Want to try again? What do you think? No, but I'll still give you credit. It's a hard one. Anybody know how to get rid of that 3? Because we do need to get rid of the 3. You're right. Michelle? Great job. That's it. So what we're going to do is we're going to raise both sides to the 1/3 power, like this. I'm going to raise this to the 1/3, and I'm also going to do that over here, because if you do 3 times 1/3, those cancel each other out, and that gives me just y plus 3 now. And on this side, I've got 1/3. Now, my guess is that on the test, they're not going to leave it as a fraction power, but I could be wrong. I'll show you what I mean, though, in the end. So I'm going to leave it like that for now. I think the last step, though, I don't think anybody's going to have any trouble with that. To get the y by itself, we would just simply minus the 3 on both sides, like this, which would give me negative x over 2 to the 1/3 minus 3 equals y. Now, bonus point, though, because like I said, I don't think they're going to leave it like this. I think they're going to change this. Does anybody remember another way, if you could tell me without any hints, another way to rewrite that? Let me try Owen. Go ahead, Owen. That's an interesting thought. I like that. That's not it, but I like your thought, because you're thinking of like how fractions make negative powers. That's not a bad thought, but that's not where we're going to go with it. What do you think, Cal? You're right. Nice job, man. Very good. So what we're going to do is we're going to make it a radical. So I think it'll be written like this. Instead of 1/3, they're going to put the negative x over 2 in a radical. Oops. Oh, that is a 2. And they're going to make the 3 goes out here. Now, technically, the 1 would go out here, but you don't have to write a first power. So I think this is what it would look like on the test on a multiple choice. I think they'll leave it like that. But I mean, as you guys can see, it's the same steps in the sense of like, put a y there, flip them, and you get y by itself. But that last thing is hard. How do you get that y by itself? Every problem is going to be a little bit different. So the first ones I showed you are mandatory. This is an extra credit. Let me show you another type of extra credit before we call it a day. Let's try this guy here. I think I'll make it this way on the homework too. You know, if you want to do the extra problems on the homework that are like these, I'll give you some extra points. Most of them are like the first ones we did, but there are ones like this as well. So, all right. Let's go ahead and try this one here. Once again, I'll give you a second to write it down. So I'm not going to ask about this first step, because I'm sure we all know that. It's just to replace the g of x with a y. I won't ask about the second step. I think we all know that. It's to switch the x and the y around. Now we're on that third step, which is to get the y by itself. So here I'll start asking for help. Anybody know what the next step would be? How do I get y by itself here? What I would do is I would add 2 on both sides first. Anybody want to take a crack at the next step? Okay, I'll take that. So Shakir had suggested changing that radical to 1/3 power. We can do that. That might be helpful. Any thoughts? Next. So I don't like that negative there in the front. So I think what I would do is I would divide both sides by a -1. When I do that, everything over here is going to become negative. I don't really need the parentheses now that that negative is gone. Yeah. Yeah, so I'm going to say it differently, but you're thinking right. We want to raise both sides to the third power, which will multiply those exponents, and then they'll cancel. And we'll do it to this side also. So this would be y equals -x minus 2. So these last two are just extra credit problems, but the first 4 or 5, or whatever we did, forget how many, those are the required ones. We'll go ahead and stop there. Once again, talk with your rides about Wednesday morning for our test corrections. Remember, you show up. We work together on your bad problems. You get half credit back for each problem you make a correction on, okay? So that's it. You guys have a good rest of your Monday.